In this video, I explain the relation kr plus 1 is equal to pq d over dp kr for binomial distribution. In this video, we also prove first four cumulants and moment about mean. K represent cumulant here. So now let's start. By definition of cumulant generating function, k of t is equal to log of moment generating function. Moment generating function mathematically represented by m of x into t. X write in the subscript. So this is moment generating function. We can already prove moment generating function, and you can find the link of theorem of the moment generating function at end screen. So as you know, moment generating function for binomial distribution is equal to q plus p e raised to power t whole power n. So put the value of moment generating function in this equation. So k of t is equal to log of q plus p e raised power t whole power n. Here, as you know, due to this power, we use power rule for logarithm, because this is log function and power present here, and we use power rule. As you know, power rule of logarithm of positive number, any positive number, we suppose positive number is m to power n, is equal to the product of n with log of n m. We can say that it is equal to the power which is here. According to this, our positive number is q plus p e raised to power t, and it is equal to the product of log of this number and the power. So n multiply log of q plus p e raised power t. We apply here power rule of logarithm. Now we derive kr. Kr is equal to dr over dtr with respect to t, k of t. Dr over dtr, put the value of k of t, which is n log of q plus p e raised power t. T is equal to 0. So kr n, taking n outside this relation, dr dtr log q plus p e raised power t bracket close, to get k r plus 1, because you can see in this equation we have k r in subscript k r plus 1. We need this k r plus 1 to prove this number. So for purpose of getting k r plus 1, we again differentiate k r with respect to t. Now we differentiate it with respect to t again. So k r plus 1, when we differentiate it again, add here 1, d over dt and dr d of t raised power r log of q plus p e raised power t, t is equal to 0. And dr over dtr d over dt log of q plus p e raised power t. Here apply the derivative by using logarithm formula. As you know, log of x is equal to 1 over x and again derivative of x. So suppose that this is your x, 1 over q plus p e raised power 2 q plus p e raised power t, and again the derivative, and take the derivative of this number, d over dt q plus p e raised power t. So n dr dtr 1 over q plus p e raised power t bracket close, derivative of a constant is equal to 0, because here we differentiate with respect to t. So any number with without t consider constant. So 0 plus p is the constant, multiply take the derivative d over dt et. As you know, d over dx e raised power x is equal to ex. So similarly, exponent with variable power variable is equal to itself. So derivative of e raised power t is equal to et. So p e raised power t. After simplification, this is the equation A. So we have kr is equal to n dr dtr log of q plus p a raised power 2t. So we differentiate this equation now with respect to p. We differentiate with respect to here we differentiate it with respect to k, and we differentiate it with respect to p. D over dp kr is equal to n dr over dtr. D over dp, d means derivative with respect to p, log of q plus p e raised power t. So apply again the log formula. Derivative of log is 1 over q plus p e raised power t d over dp. Again the derivative of this number. As you know, p plus q is equal to 1 and q is equal to 1 minus p. 1 minus p plus p e raised power t. Apply derivative here. Derivative of a constant is equal to 0 minus dp over dp is equal to 1 plus e raised power t. So multiplying both sides by pq. Pq d over dp kr is equal to npq dr dtr et minus 1 q plus p e raised power t. T is equal to 0. This is equation B. Subtracting equation B from equation A. Subtracting equation B from equation A. So equation A is kr plus 1 minus pq d over dp kr is equal to kr plus 1, this number, minus this number. So k r plus 1 is equal to n dr over dtr p e raised power t q plus p e power t, t is equal to 0, minus this equation. Both equation of A and B, subtract its right side and subtract its left side. So here subtract its left side. Now write this number npq dr or dtr et minus 1 q plus p e raised power t. Now we differentiate. Np is the common in both numbers. We take common np, and dr over dtr is also the common in both terms. So we take this common, and here we can take LCM of q plus p e raised power t. After taking this LCM, here we left et because p is already, we take common outside the equation, minus q into et minus 1. So q is equal to 1 minus p. Multiplying et into 1, e minus et plus minus minus plus p e raised power t plus q. Cancel out these two terms, and then q plus p e raised power t, q plus p e raised power t. Cancel out these two terms. Here we left with 1. T is equal to 0, and its derivative of constant is equal to 0. So 0, and k r plus 1 minus pq d over dp kr is equal to 0. Take this minus term on the right side. So we can say that kr plus 1 is equal to pq d over dp kr. Hence we prove this relationship. Now our next question is to find 4 cumulants and moments about mean. So by definition of cumulant generating function, cumulant generating function is represented by k of t log of mx t. I write this equation as 1. M of xt, which is the moment generating function of binomial distribution, is equal to q plus p e raised power t whole power n. So put the value of moment generating function in equation 1, log of q plus p e raised power t whole power n, using here power rule for logarithm, which is equal to multiplication of power and the log of the number. So n log of q plus p e raised power t, taking derivative both sides, d over dt k of t, n taking outside n d over dt log of q plus p e raised power t. So log of x is equal to 1 over x dx over dx. N again taking the derivative of log, which is 1 over q plus p e raised power t d over dt q plus p e raised power t. N over q plus p e raised power t d over dt q plus p d over dt. As you know, the derivative of a constant is equal to 0. Derivative of exponent power x is equal to x itself. So put this value here, p e raised power t n p e raised power t over q plus p e raised power t is equal to 0. Apply 0 where you see the t. So e0 is equal to 1. We left with np over q plus p. Q plus p is equal to 1. The derivative of first cumulant, which is k1, is equal to np. Now consider the relation to find out second, third and fourth cumulants. We already proved this relation in this video. Kr plus 1 is equal to pq d over dp kr. So put r is equal to 1 in equation b, which is k2 is equal to pq derivative of with respect to p k1. In this equation where you see r, put r is equal to 1. So k2 pq k1. So put the value of k1, which is np. N is the constant. Take the outside from derivative npq dp over dp. Derivative of dp over dp is equal to 1. So we prove that k2 second cumulant is equal to npq. Put r is equal to 2 in equation b. When put r is equal to, this becomes k3 pq d over dp k2. So put the value of k2 npq. Take n outside common, npq d over dp. Here we left with pq into 1 minus p. Multiply p inside p minus p square. Again apply derivative inside dp over dp minus d over dp p square. Using power rule, which is x power raised power n into n x n minus 1. npq d over dp 1 minus 2p. So we have npq into 1 minus 2p. Putting the value r is equal to 3. So in this relation, put r is equal to 3. We have k4 is equal to pq d over dp k3. So k3. Put the value of k3, npq into 1 minus 2p. Put the value of k3, npq into 1 minus 2p. k4 is equal to npq, take n outside, p, put the value of q 1 minus p. As you know, q is equal to 1 minus p and q plus p is equal to 1 minus 2p. Multiply p inside. First multiply these two terms with each other. 1 multiplied by 1 minus plus 2p square minus p into 2 minus plus 2p square. So and then multiply p inside again. P minus 2p square minus p square plus 2p power 3. We simplify it as p minus 3p square plus 2p power 3. Apply derivative inside. As you know the rule for applying derivative of subtraction and addition, applying derivative to each term and the sign remains the same, minus as it is and plus as it is. By using power rule, which is n into x into n minus 1, 1 minus 3, when we apply the power rule, multiply this power with the integer, we left with 3 multiplied by 2, 6, and decrease p power 1, we left with p, plus similarly 6p square, 1 minus 6p, taking 6p common, 1 minus p is equal to q, npq into 1 minus 6pq. So our k4 is npq into 1 minus 6pq. Now we find the moments about mean. First moment about mean, mu1 is equal to mu1 prime minus mu1 prime is equal to 0. Cancel out when these two, it is equal to 0. Second moment about mean, mu2 is equal to k2. Second moment about mean is equal to second cumulant, and we already proved second cumulant, which is npq. So the second moment about mean, which is mathematically represented by mu2, is equal to npq. The third moment about mean, mu3 is equal to k3. The third moment about mean is equal to third cumulant, which is npq into 1 minus 2p. We simplify it as we write minus 2p as minus p minus p. It is also equal to minus 2p. 1 minus p is equal to q. So we can write it also as npq into q minus p, which is the third moment about mean. Fourth moment about mean is mu4. It is represented by mu4 and it is equal to fourth cumulant plus 3 second cumulant square. So here write fourth cumulant, answer of fourth cumulant k4, which is equal to npq into 1 minus 6pq. Write this fourth cumulant here, I write here, plus 3 into second cumulant is equal to npq. Write here npq whole square. So taking npq common outside, because this is the first term and we have here npq, and this is the second term, we also have here npq. When taking npq outside, 1 minus 6pq plus 3 npq. Hence we solve our 4 moments about mean and cumulants. If you want to see videos about moment generating function of binomial distribution, mean and variance of binomial distribution, then click the link in front of your screen. And you can also find the videos about solved proof of all distributions of discrete and continuous in this channel Statisticians Club. Please subscribe the channel Statisticians Club to get more videos about probability distribution. Thanks for watching.